Okay. Good morning, guys. Good morning, Yasmin. Good morning, Marco. Good morning, Angela or Angelica. Take attendance real quick. Garcia, perfect. Marco, perfect. And Akaza's here. Joshua's good. There he is, perfect. Colocho, let me get her in. Perfect. Okay, we'll get started about 9:02. Today's lesson is easy. Easy. It is easy. All right, so 9:02 we'll get started. Not allowing that person to come in. I think I can message him, right? Oh, there's Barnaby. That is no problem. Yes. For Joshua Gonzalez, perfect. Jesse, thank you. All right, cool. All right, Anna Luna, you're good. Luna, Jesse, you're good. Marco, I marked you here. Samantha, perfect. Okay, Luna, good. No, yeah, Josh is good. Alan, no. Alan, Ulysses, no. Adolfo, no. Anna Cause, I'm surprised. Anna Cause, I'm actually very surprised that she is not here. Huh. Very interesting. All right, we will get started then. Okay, I've got 10 kids marked present, so we are good to go. Okay. Yes, Anna Cause, I do mark you here, so you're good, Anna Cause. You're fine. You're totally fine. Okay, let's get to it. I do want to tell, I actually have a few more people here in the waiting room. Oh, Alan and Adolfo. Perfect. Okay, Alan Gomez and Adolfo Cruz. Perfect. Where's Adolfo? Boom. Alan, boom. And oh, Josue. Perfect. Josue. Perfect. Cool. Okay. Real quick, I will say that I've updated grades and they have not really changed. Remember, office hours. As I'll show you guys on the screen here, do not forget about office hours. I have office hours from 2 to 4 every day, including Friday. I've got 2 time slots today, 3 and 3:30, so from 3 to 4 today, and a few rules, and I'm free the rest of the week. A few rules. If you do not show up twice in a row, or if you fail to show up 3 times the rest of the semester, your only scheduled office hours is only going to be after class, and that is it. Okay, you will only be getting a half hour per session. I will not be extending office hours past a half hour. This means do not wait until the end of May to raise your grade. You will suffer. Okay, you are going to suffer. 10? Why 10? Why? There's no 10 anywhere. No name change. Whoever period 1 is, I'm not letting him in, by the way. Okay. No admittance. Okay. With the whole Zoom Bob and all that stuff, I'm not taking any chances. So that P1 kid, if that person's trying to log in, well, I don't know who that person is, so therefore they're not coming in. They got to change your name. Okay. So that's not cool. I'm not gonna let that happen in any case. Okay, you have quizzes. They're due, right? You have homework. They're due. Do not forget also that you guys have test corrections that you guys can do as well to fix your grades, okay? Any questions there? Because I'm being very fair. I'm trying to be as fair as I can to help you guys raise your grades. I leave it up to you. It is not up to me if you guys want to fix your grades. So definitely keep that in mind, all right? So in any case, Axel, you're good. Thank you so much. So let's get to it. Today's lesson is super de-duper simple. So here we go. Okay. We're talking about rewriting radical expressions, okay? This table shows the relationship between the area of a square, the side length of a square, and the square root of the area. A square with a length of 4 and a side of 2, okay? Or area of 4 and a side of, has a side length of 2, right? Because 2 times 2 is 4, and the square root of 4 is 2, okay? So let's talk about now. Can you schedule office hours tomorrow with you? Yes. Marco, you can schedule me office hours at 2 o'clock tomorrow if you'd like. Perfect. So I'll send you a link later today or tomorrow. Okay, be aware of your schedule. So let's look at this. For this here, what is the side length of a square with an area of 49 square units? Can anyone tell me if I have a square and the area is 49? And we know the sides are the same. What would the sides be? Anybody? Good, Colocho, because 7 times 7 is 49, okay? Now 20, that's where it changes things, okay? There's no whole number for 20, but we need to figure out where 20 could be between. Like what side length would give you an area of 20? Where could it be between? Okay, is the big question. Okay, so I'm going to zoom in and let's talk about square roots. Okay, when we talk about square roots from the square root perspective, where would 20 be in between? Good, Josue, awesome job. Yes, 4. Why? Because 4 comes the square root of 16 and 5 comes from the square root of 25. Josue, that was amazing. Tears of joy. That was phenomenal. Okay. Any questions on how we got that? Any questions on how we got that? Okie dokie. All right. So let's move on to the examples because I think you guys are getting the idea. Okay. You guys are getting the idea in any case. Okay. We're going to use properties to rewrite radical expressions, okay? So how can we visually show 16 is equivalent to 2 radical 4? We'll keep this in mind, okay? What we're doing here is square root of 16. We know that it technically comes from the square root of 4 plus the square root of 4, okay? So in this case, when we add them up, well, actually, it's not really that. So in any case, that wouldn't really work because the square root of 16 comes from 4 multiplied by 4. So it's not going to be addition essentially, okay? So this is not going to work. Visually, it's impossible. But what we can say that we can't compare radical 20 and 2 radical 5 using what's called the product property of square roots. Remember this. If we have 2 numbers inside a square root, we can split them up into 2 different square roots. Okay? Very, very important. Okay? So in this case, that makes sense. Okay, so let's rewrite radical 20 as a product of square roots, okay? Now, we can do it this way. We can do it in the way where we can figure out 20 makes radical 4 times radical 5, okay?
Mr.
Oh, I see that. Yes.
Can you add and then multiply 2 together or only multiplication?
It's inside its multiplication. That's a good question, Sophia. When the numbers are outside, you have to add them, but keep this in mind, okay? 3 radical 7 plus 2 radical 5, that's it. That's as far as you can go because radical 7 and radical 5 are different. It's like saying you're adding x and y together, but you can't, okay? Good question. That's going to come up later today, okay? It's going to come up later today. For this particular question, though, what we're doing is we're trying to split it up like this, okay? And notice how I can split up radical 20 into 4 times 5, okay? And then 4 times radical 4, I can write it as 2 times 2, which becomes just 2. Now, this is, in my opinion, confusing, confusing, Ulysses needs you to accept him. Perfect. I got him in, so we're good to go. So Ulysses, thank you. What we're going to do instead, I don't know if you guys have ever seen this before. Have you guys ever seen what's called the factor tree? Just one of you guys tell me either yes or no. Okay, that's easier in my opinion, okay? I'm not saying this looks confusing. I'm saying that this looks a little more organized. And what you're trying to do is find pairs, okay? You're trying to find pairs in which you make 20. So give me two numbers that multiply to 20. Anybody? I'm looking at 10 and what?
10.
No, that's 10 plus 10.
10 and 2.
Good job, Samantha, 10 and 2, okay? Now, 2, there's nothing else because it's only 2 and 1. So that's a prime number. We're done with that number. But I can split up 10. How can I split up 10?
5 and 2.
Very good, Samantha. Very good, Sophia. 5 and 2. So whatever pairs we make, that's going to go outside of the radical now. So every pair that we make, we're going to put it outside. And whatever pair we do not make, we're going to leave it inside the house. That's why we got 2 radical 5. So notice how it's exactly like this. We just did it a different way. In my opinion, I feel like this is easier, in my opinion. Okay? Any questions on how we got this? Okay. So let's go ahead and practice real quick. Okay, we're making comparisons of each radical expression, radical 36 and 3 radical 6. Okay, so let's do the work here on the side. Let's see if we can make it, okay? So radical 36, how does 36 break up? 6 and 6. Do we have a pair? Looks like we do. So guess what? The square root of 36 is 6. We're done. And notice how they're not the same, okay? They are not the same, okay? So guess what? This one, no bueno, no sirve, okay? So, and yes, 12 and 3 also works. So let's actually use Samantha's idea, okay? If I did square root of 36 and I did 12 and 3, 3 is done, but how can I break up 12?
2 and 6.
Good job, Marco. 2 and 6. How can I break up 6?
2 and 3.
Very good. 2 and 3. Notice beep, ba, 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 boop right there. And then beep, ba, 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 boop. I got 2 pairs. So now it turns into 2 times 3, but 2 times 3 is 6. Same thing. Samantha, thank you for showing me that example. Perfect. So now let's do 72, okay? Let's do 72. Now, this is for an extra credit point. Okay, not the numbers, but every even number is always divisible by what?
2.
Who said that?
Sophia.
Sophia, thank you. You get an extra credit point. Every even number is divisible always by 2. So if I divide 72 by 2, what is 72 divided by 2? Should have a calculator in front of you or Desmos it. $36. And now notice how I can break down 36. Both can be the same, right? Both numbers are technically the same. Let's do, okay, we'll do 12 and 3. That's fine. Let's do 12 and 3 for Samantha's case. 12, I can break down 12. As we already did, it's 6 and 2. And then for 6, it's 2 and 3. Notice how I've got a pair of 2s, okay? And then notice how I've got a pair of 3s. So what I'm gonna do is I'm gonna take out the 2 and the 3. That's gonna be outside and it's gonna be multiplied together. And then inside the house is gonna be this number that I did not pair. So then it becomes 6 radical 2. Okay, and then if you notice, haha, it does work. CC or B. Okay, any questions on this? Okay, this is easy, right? This should be easy. Burnaby, how you feeling? Are you feeling regular, Burnaby? Okay, I'm glad you're feeling regular. Okay, same thing with this. Okay, let's do some more practice. We're going to do something like part B in a sec, but let's do part A here, radical 44. Okay, all right, so let's do radical 44 here on this side. Boop, boop, boop. In fact, let me ask a particular student and see if he's paying attention. If not, I'm going to call mom and dad right now. Good. Actually, no, I'll call him maybe after class. Jesse, give me two numbers that multiply to 44. Either you can tell it to me or type it to me. Jesse, can you tell me two numbers that multiply to 44? Good job, Sophia. Good job, Anna Kaz. But I'm looking for Jesse. Good job, Thank you, 2 and 22. Thank you for paying attention, Jesse, by the way. Perfect. We're going to take Jesse's ordeal, 2 and 22, because 22 breaks down to what, anybody? Good job, 11 and 2. So I'm going to put 2 right here, 11 here, beep, bop, boop. I got a pair. So I take out the 2, 11 stays inside, bing, bang, boom, you're done. Any questions on that? Not 1 and 11. Remember, it's 2 and 11, right? Not 1 and 11. Okay. Let's move on. Let's do now what happens. Oh, no, there's a number. What if there's a number outside? Well, that number does not get touched. It's going to go along for the ride. Let's only worry about 27. Two numbers that multiply to 27.
4 and 7.
No, that gives you 28. 9 and 3, perfect. 9 and 3. And can I break down 9? What does 9 break down to? 3 and 3, very good. So I got a pair. Now, this number multiplies with the number outside. So now I've got 3 times another 3, and then left inside is this number I did not pair with, the 3. So then the final answer, which 3 times 3 is on the outside, it's going to be 9, and then radical 3. Any questions?
Mister, it looks easy when you do it, but when we do it for homework, it looks so hard.
Because you're applying the skills, kids. You guys are applying the skills, okay? So you guys are applying the skills that we're learning. So again, my thing is watch the videos, okay? Watch the videos, okay? When we leave class, you're turning on your brain, and then you're applying the applications, okay? So let's move on. Here we go. Oh no, there's an X, okay? I'm going to teach you guys a trick, okay? I'm going to teach you guys a bit of a trick. It's actually easier in my opinion, okay? So we already broke down 63, okay? We already know that it's 3 radical 7. We already did that earlier, okay, from the question. But what I want to worry about is the X though, okay? So what I'm going to do is I'm going to take the 9 and divide it by 2. Can anyone give me the decimal? Wow, I just gave you part of the punchline. What is the decimal form for 9 over 2? 4.5. Good job, Allison. Here's the kicker, okay? If there's a decimal, okay, that means there's going to be an X left inside, and then whatever this number is, that's how many X's there are going to be outside, okay? That's how many X's are going to be outside, okay? So let's focus, let's do 2 things, okay? I'm going to change this 3. Instead of a 3, I'm going to change it to an 8. Actually, that's a terrible 8. Actually, let's go 12, okay? If it's not a decimal, there's no X inside, okay? So here's the kicker, okay? I'm going to put this here. No decimal, no X inside. You always want to divide whatever the exponent is by 2. That's important, okay? So I'm going to change that 3 to a 12 to make it a little bit easier, okay? So here we go. So we have the square root of 25, x to the power of 12, okay? We know what the square root of 25 is. What is the square root of 25? That's easy. 5. Good job, Allison. Now let's focus on x to the 12th, okay? X to the 12, if I divide that by 2, it's x to what power? Good. Oh, I didn't see that there. Good. 6. Okay, perfect. There's no decimal, So it's going to be 5x to the 6th power. Now, there is a reason why we're dividing by 2. And I'll give you a hint, okay? A little bit of a hint. If there's no number right there, that means what number is supposed to be right outside the radical, which is why we're dividing by 2? And I'll give you a hint. It's right in front of you. It's right where the cursor is. That's for an extra credit point.
X.
Was that Anna Kaz?
No, me.
No.
Was that Sophia?
Yes.
It is 2. Okay, it was 2. Marco, sorry, it was, I know, you were close though, okay? If there's no number there, there's automatically a 2 on the outside, okay? So let's actually separate the men from the boys now. What if I did this, okay? The square root of x to the 11th, but then there's a 3 right here. What am I gonna divide the exponent by? This should be obvious because we've done this before,
3.
Not 2. 3. Remember, it's power over root. Okay, power over root. Okay, that's really important. Okay, and if we use long division to actually rewrite this like this, oh, that's definitely not. That's what I wanted to do. Like this. Okay, 11 divided by 3. 3 goes into 11 3 times. Okay, 3 times 3 is 9. The remainder is 2. That means this is going to be on top of the x. But then I'm going to leave 2 x's inside. So it looks like this, okay? This will come up later on, not in this chapter, but it'll come up later on overall, okay? Don't want to confuse you guys. We're only going to focus when there's a 2 on the outside. So let's go ahead and do this one here. 5 radical 4x to the 17th, okay? So for this one here, we all know what square root of 4 is. What's the square root of 4? 2. Very good. Okay. But now let's work on the 17. 17 as or when I divide it by 2 as a decimal, what would it be? $17 divided by 2. Good job, Allison. 8.5. Okay. So that's a decimal now. That means I need to leave an x inside. And then outside, I have 8 x's. And there you go. Okay, any questions on this? Okay, it's doable, guys. It is doable, okay? Oh, no, what if there's 2 of them? Here's my hint, okay? Combine them all. Don't do this, okay? This is going to be really confusing, okay? Let's do what we have learned how to do using this. The product property of square roots. So you're going to multiply the numbers first inside the radical and then outside the radical and then break it down. So let's do part A first, okay? All right, here we go. So I'm going to convert 1/2 is 0.5, okay? And then I've got a big radical, 21x to the power of 3, okay? Multiplied by, I think it was a 4 on the outside. Yeah, 4 multiplied by the radical of 7x to the power of 2. Okay. So let's rewrite this, okay? Let's focus, first of all, on 0.5 times 4. Whatever's outside, we multiply those together. What is 0.5 times 4? 0.5 times 4, not 0.2. Very good, Allison. It is 2, okay? Now, we're going to multiply 21 times 7. What do you get when you multiply 21 times 7?
147.
147. Very good. Okay. And then lastly, remember we're adding these exponents. We're not multiplying. So how many x's do I have altogether when I add them?
2?
No.
No, 5.
Yes, 5. Very good. Okay, so now let's break down 147 as far as we can. Okay, now I'll give you a hint. 21 and 7, they're both divisible by what? Actually, yeah, 3. That works. 3 does work. So let's divide 147 by 3. What do you get when you divide 147 by 3? 49. Ooh, good job, Colocho. And with 49, guess what? What does 49 break down to?
7 and 7.
Very good, 7 and 7. So that means I'm going to have a 7 outside with the 2. So I'm going to have 2 multiplied by 7. And then inside the radical, I have this 3. Okay, now let's worry about the x's, and I'll put this over here on this side. Okay, if I divide the x, the 5 by 2, what is the decimal for 5 divided by 2? Or whole number?
2.5.
Very good, 2.5. That means I got a decimal. That means I need to put an x inside. And then outside, I got x squared. While actually, I'm not done because I got to multiply 2 and 7. What do I get when I multiply 2 and 7?
14.
Very good. So 14x squared, radical 3x. Voila, now you're done. Any questions? It is doable, kids. It is doable. Okay. Yes, and 2 times 7 is 14. Thank you. Okay, last one here. So let's multiply 12 and 18. Okay, let's actually rewrite this so that we can do the work on the separate sheet of paper. So there's going to be a 2 on the outside. Okay, 12 times 18, anybody? No. Where'd you get 30 from, Josue? 216, perfect. All right, 216. How many x's do I have altogether?
14.
Very good, x to the power of 14. Okay, so we have 2 radical 216 times x to the power of 14. Perfect. Okay, so do beep bop boop 216 x to the 14th. Let's break down 216. It's even, so it's divisible by 2. Let's divide 216 by 2. What do we get? And a cause, remember, we're adding the x's together. 9 plus 5. We don't multiply the x's. We add the x's. Keep that in mind. Yes, 108. That's still divisible by 2. So let's divide 108 by 2. $54. Okay, I'll let you guys tell me what we can break down 54 as. Your choice.
3
And
18.
okay, and I can break down 18.
Yeah, 9 and 2.
9 and 2, and I can break down 9, right? What does that
Yeah.
break down to? 3 and 3. Good job. And yes, Samantha, good job. And yes, Allison, good job as well. Okay, let's circle all the pairs. Okay, beep bop boop, and then beep bop boop. Those 2 numbers come outside. So it's 2 times another 2 times times a 3. Okay, now let's worry about the x. Okay, x to the power of 14, divide that by 2. 14 divided by 2, which would be 7. Good job, Allison. So that means there's going to be x to the 7th on the outside, and there was only a 3 and a 2, 1 3 and 1 2 that I did not pair, and that stays inside. So now our final answer, I'll put it over here. 2 times 3, that's 12. X to the 7th, and then radical 6. Bing, bang, boom, that's it. Okay, any questions on this? Remember, I am recording this, just a heads up, okay? I am recording this, so if you want to go back and review the lesson, you're more than welcome to, okay? Oh, that's not it. This is it. Okay. So with this one here, this is not that bad actually. 5 times radius. Okay, so so we're talking about now ice cream shops here. A light fixture in an ice cream shop is in the shape of an ice cream cone, and the cone has a height of 7 times that of the radius. The expression here is given where we square with the radius squared and we add it with the height squared, okay? The slant height should be no longer than 24 inches to fit the wall. What is the slant height of the cone with the radius shown? So here's the radius. We're trying to find the slant height, okay? So we need to determine how to rewrite this so that we can find r. Well, we know that the height is 7 times of the radius. So we can say that the height is equal to 7 times r. I'm going to replace 7r in for h, and bam, we get 49r squared. These are the same, so we add all the r squareds together, we get 50r squared. We then break it down, we get 5r radical 2, okay? Then we're going to plug in 3 for r since 3 is the radius, and then bam, we see that it's 21.2, okay? So let's do this on a separate sheet of paper. This one's not hard. What is the simplified? Oh, we're just looking for the simplified expression, so we're not looking for anything else, okay? So we know that h is equal to 5 times r, and we're using this, r squared plus h squared. I'm going to make the substitution for you guys to make it easier, okay? R squared plus 5h squared. I'm substituting. So in this case, what does 5h, not 5h squared, 5r squared. Sorry about that, guys. Okay. What does it become? Not this, but rather this. This 5r squared.
2.5.
Say that again, Sophia?
5.
Yes, 25r squared, okay? And we can add up all the r squareds together. 25 plus 1, what would that be there?
26.
Very
squared.
good, Marco, 26. So it's 26r squared. So now let's break down 26. Good job, Samantha, by the way, too. Let's break down 26.
2 and 13.
Yes. Guess what? That's as far as I can go. So there's no pairs that I can make. However, let's focus on the r squared. R squared divided by 2, what does that become? It is 1. So guess what? I'm going to have an r on the outside. So there's an r on the outside, and then these are left inside. So it's r radical 26, because 2 times 13 was 26. Voila, yeah, done. Okay, that concludes our lesson for today. Sophia, I know you wanted to stay, so you can stick around if you like. You said you had a question on the quiz, right? Sophia? Is she there? Sophia?
Yes, mister?
Oh,
Yes,
you're there.
yes.
Okay. Just wonder if you want to stick around, if you want any help on the quiz. Oh, there you are. Yes, I didn't see that. And then Joshua, if you want to stick around too, you're more than welcome to as well, obviously, if you wanted to talk. Sophia, you're going to be first. Okay. So if you want to stay, because I'm going over some stuff on the quiz, you're more than welcome to. If not, I'll just break everyone, or I'll break people up in break those who want to stay in a breakout rooms. You have a quiz that is due by the end of tomorrow. Remember, if you don't submit them, you lose points. If you don't submit them at all, you lose 5 points. Okay? Any questions on that? Okay. If you want to stick around, you're more than welcome to stick around. Sophia, you're first, and then Joshua, you're next. Okay? So let's look at the quiz. Okay? I'm only going to go. Which one do you have a question on?
I think it's a 5. And
Number 5?
1.
Okay, let me stop recording.